Note card 39, we're going to be adding and subtracting rational expressions. So let's just get started with an example. Okay, remember what you have to have before you can add or subtract fractions. You must have a common denominator. And when you have a common denominator, you just add or subtract the numerators and keep that denominator. And with example 1, we already have a common denominator, x plus 5. So I have x plus 5 as my denominator. And so I have 2x plus 1 on top on the left. And then minus 3. And then I want to combine my like terms. On top I have 2x plus this 1 minus 3 is a minus 2, so it's going to be 2x minus 2 over x plus 5. Then we want to go back to right here. All we're doing is simplifying a rational expression like on the note card 38. So I want to factor if I can and see if something cancels. And so on the top I can factor out a 2. That leaves me with x minus 1 over x plus 5. Nothing else factors, nothing cancels, so this would be my answer right here. And this one was pretty easy because we already had a common denominator. And I will caution you now, whenever you're adding, you're just adding the numerators, the top numbers together. But whenever you do a subtraction problem, if you ever have something more than one term on the top on this right piece over here, focus right here. If I had something more than this minus 3, I would need to open up a set of parentheses. For example, and I'll just start this problem. If I have, let's say, x plus 4 over x minus 1 minus 3x plus 5 over x minus 1. Well, my denominators are the same, so I can just bring that on down over here, x minus 1. So I have x plus 4. But when I begin my subtraction now, because this subtraction sign applies to both of these terms, I must open up a set of parentheses so that I distribute this minus sign throughout and apply it to each term. So be very careful with that. Okay? Let's look at example 2. Okay, so what we're going to do here is before we can add these, we have to have a common denominator. Well, if I give you a quick review of adding and subtracting fractions, let's say we have 1/2 plus 3/4. Well, the first thing that I would want to do is find my least common denominator, and we should all know that that's going to be 4. Write that down. What did I do to this 2 to get to 4? Well, I multiplied it by 2. Okay. So 2 times 1 is 2. And then this 4 stayed the same, so this 3 stayed the same, and I end up with 5 over 4. Okay? Another way of looking at this problem, sometimes when you're adding and subtracting fractions, it's not that easy to find that least common denominator. So what you could always do is multiply the two denominators together. So 2 times 4 is 8. I could use this as a common denominator. It's not the least common denominator, but it is definitely a common denominator. And so what I do here is What did I do to this 2 to get to 8? I multiplied it by 4. What did I do to this 4 to get to 8? I multiplied it by 2. So I must multiply this by 2, and I get 6. And I get 4 plus 6 is 10 over 8, which still reduces to 5 over 4. So we're going to use this idea with what we're doing over here with this rational expressions. It's kind of hard to determine what the common denominator between x plus 2 and 4x might be. And so I'm just going to multiply them together. So that's our first step. When we don't have a common denominator, we multiply the two denominators together. And so I get 4x times x plus 2. And then what did I do to this x plus 2? Well, I multiplied it by 4x. So what I can do here, there's a simple model that we can use, and basically it's going to be bottom times bottom, which I just did, and then I'm going to multiply the top term of the first fraction times the bottom term of the second, so that'll be 5 times 4x plus, and then the top term of the second fraction times the bottom term of the first fraction, 3 times x plus 2. Now let's go back and make some sense of this based on what we did a second ago with our review of fractions. First we multiplied our two denominators together, and then what did I do to this denominator? Well, I multiplied it times 4x. So I must multiply this top times 4x. What did I do to this denominator to get to this over here? I multiplied it times x plus 2. So I must multiply this top times x plus 2. And the easy way to remember that is bottom times bottom, then this top times this bottom, and this top times this bottom. Now what we want to do is we want to simplify, see if we can factor, and see if we can simplify this as far as we can possibly simplify it. So this becomes 5 times 4x is 20x, and then I distribute the 3, and I get plus 3x plus 6 over, I'm going to go ahead and leave the bottom in factored form, because what I'm going to try to do here is I'm going to try to take this top part of my fraction, this numerator, and see if it'll factor and see if something might cancel out. And something might cancel out and something might not cancel out. But we want to try, you can just leave this as a rule of thumb, just leave your answers all in factored form. And so just leave this bottom in factored form, and hopefully when I factor this top, something might cancel out. But even if it doesn't, it'll still be correct if it's in simplest term. So the first thing I want to do is I want to see if this top, first, well, I have to combine like terms. So I have 23x plus 6 over 4x plus x plus 2. And as I can see that nothing factors here. There's no common term between 23 and 6. And so we're done right here. This is finished. And so that's how these work. Let's look at one just a little bit more complicated. Okay, so I have 3 over x squared plus 3x minus 1 over x minus 6 over x squared minus 9. And so I have a three-way subtraction problem here, and I need a common denominator, so I'm just going to go ahead and multiply all my denominators together. So I have x squared, or I'll put the x out front, it'll make more sense to do that, times x squared plus x times x squared minus 9. So what did I do to this denominator? I multiplied it times x squared minus 9. So that makes this 3 times x squared minus 9. Okay, I'll say that again. This denominator right here, I multiplied it by x and by x squared minus 9. So I have to multiply this 3 times x and times x squared minus 9. Okay, thank you. Okay, then now I have minus, what did I multiply this x by? I multiplied it by all this, but I'm going to open up a bracket or a set of parentheses indicating that this minus sign is going to have to go to all of this. So I multiplied this x by both of these denominators over here, so I'm going to multiply this 1 by both of these, which just gives me x squared plus 3x times x squared minus 9 okay, and then minus, open up another bracket so I can distribute this minus sign. I multiplied this x squared minus 9 to all this stuff here, so I'm going to have this times x squared plus 3x. Okay, so we have just a lot of simplifying to do. Now what you should be able to notice in here, there's going to be a lot of x minus 3 and x plus 3. This stuff can factor. But first what I want to do is, let's just begin by simplifying. Thank you. So I'm just going to start first of all by just simplifying. And sometimes it doesn't really matter which order you go in. What I'm going to do is I'm going to begin to simplify inside of each bracket here and distributing here. Well, first what I'm going to do is this piece right here, factor it. So this becomes 3x times x plus 3, x minus 3, minus, and I'm going to keep my bracket for a second. This, when I factor this piece out, it's going to be an x comes out, and I'm going to be left with an x plus 3. And then this x squared minus 9 becomes x plus 3, x minus 3, close my bracket, minus, continue with my bracket over here. I have a 6x, and then this piece right here becomes, I'm going to be able to pull out an x, so times x, and then that becomes x plus 3, close my bracket. And then on bottom, I'm going to go ahead and factor all this out. I'm going to have an x times x, and then x plus 3, and then times x plus 3, x minus 3 for this difference of squares here. And we have a lot of factoring going on here, a lot of stuff. But what I want to look at now, I want to see if something cancels. Now what you have to realize here, without me making too much of a mess, because I've got a lot of stuff here, is that we have 4 parts here. This subtraction sign divides the top into 1, 2, 3 pieces. And then there's a 4th piece on the bottom. In order for things to be able to cancel out any common terms, I must have that common term inside of all 4 pieces. So I noticed something as I was doing all this factoring is that they all seem to have an x plus 3. This one has an x plus 3, this one has an x plus 3, this one has an x plus 3, and this one has an x plus 3. So I'm going to go ahead and cancel those x plus 3s. Just one from each one. Something else I've noticed is that each term seems to have an x all by itself. This one has an x. This one has an x. This one has an x. And then this one has an x. So I can cancel one of those x's from each one. And so let me make myself a little more room here. So I'm going to rewrite this now what I have left. I have a 3 times x minus 3 minus. Here I have a minus x plus 3 x minus 3. That's all I have left here because all this canceled. And so there's no need for a set of brackets here because there's multiplication. That minus sign applies to both. And then here I have a minus. What's left here is just going to be a 6x because this all canceled. So minus 6x over x times x plus 3x minus 3. Now from this point, if I'm looking at all three terms, what I'm going to want to do now is it looks like nothing else is going to cancel within all four terms, this one, and this one. All four of them do not have something in common. This one has an x minus 3, this one has an x minus 3, and this one on bottom has an x minus 3, but this one on top doesn't. So I can't do anything with that x minus 3. So the next thing that I'm going to want to do is I'm going to want to simplify. I'm going to keep my bottom factored. Okay, and leave it like that. But this top, what possibly can happen is if I distribute this 3, if I FOIL these and combine like terms, it's likely that I'll have another polynomial that I can factor and get something in common here that might cancel out with on bottom. So I'm going to distribute here, and I'll have a 3x minus 9 minus. This is just a difference of squares, so that's just x squared minus 9. I'm going to leave that in parentheses because now this is becoming something that I'm going to be able to distribute this minus sign through. Minus 6 over x times x plus 3, x minus 3. And so if I combine like terms now, well, continue to simplify. If I continue to simplify, I will have 3x minus 9, distribute this minus sign, minus x squared plus 9 minus 6x So combining like terms here, I have a minus x squared. That's gone, so I can cancel it. Then I have a 3x minus 6x. That's going to be minus 3x. And then my 9's just, they cancel. So all I have on top then is a minus x squared minus 3x. And on bottom, I have an x times x plus 3, x minus 3. Easy factoring on top, GCF. Remember when there's a minus sign out here? I want to take that minus 1 out as well. So I'm going to factor out a minus x. And that's going to leave me with an x plus 3 over x times x plus 3, x minus 3. And see, so now I see that some things are going to cancel. So this x cancels with this x plus 3 cancels with this x plus 3, and I'm left with minus 1 over x minus 3, and I'm finished. And so I'm done. And so the idea here is to make sure that when you do a problem like this, this last one, there was a lot there. It wasn't that there was very many things complicated in it, but when you get so many things together, it gets very easy to, as you saw me a couple times, not when I'm recopying something, I might leave something out. And so just pay very close attention. Give yourself plenty of room on your paper. Definitely use pencil so that you can erase if you make a mistake. And that's it.